of you will drop off in the middle. Some of you will drop off maybe in the first 10 minutes. But just to announce something, I have a cash prize at the end of this session. So if you like, you can go. It's your choice, to be honest. So yeah, and we're going to dive right into it. So I'm going to share my screen. Let me know if you can see it and if the audio is also good in the chat, please. Okay, we're good? Great. So now let's dive right into this. So, like I said, today we're trying so much to kind of make it very hands-on, a hands-on session, very interactive. I will try as much as possible not to explain things like, in the textbook definition kind of way. And before we start, though, I would just like to, touch the room and all and just see our level. So how many of us here are cloud engineers? You can just drop it. And what level would you say you're in, whether beginner, intermediate, or advanced, so that I know how I'm going to stick to this session, whether I'm going to use analogies, whether I can speak technically free, So I'll just like to, know what we're working with today. Okay. Great. Any level before beginner? We'll leave that one for God. Okay. So we have intermediate, just one person. Okay. We have another beginner. Okay. Great. Are you guys shy to type or something? Okay. So I've already seen like beginner. Okay, front end devs, beginner. Okay, so today we're going baby friendly. Okay, not baby friendly, but friendly. Let me not use the word baby. Okay. So I would assume that most people here have foundational knowledge of, deployment and all. For the front end engineers in the house, I'm sure you're used to using things like Vercel, what's the name of those other ones? Calify, maybe, Render, and so on and so forth, right? Great. But most of the times, I know we learn to code, right? We learn how to use frameworks. We learn to build features and all of that, right? But at the same time, a lot of us do not know how to ship, right? So many people don't know how to get their code from the local host to like production server and allow it to handle a lot of traffic. So sometimes when things go wrong, a lot of us don't even know where to start. Some people prefer to use things like Vercel and Co. for, I'll call it maybe their dev platforms, but on production, most people will move to cloud providers, right? So today, we're supposed to talk about, how to ensure you ship properly. And by the end of this session, I'm going to show you like a working deployment pipeline that's from code pushing to a live app. And I hope you all understand every piece of it. So we're going to get right into it. Okay, so this is a question to the room. Who here has ever tried to SSH into a live server to fix something? You can just, raise your hands or something. Like, how many of us have ever done that? Okay, I can see a lot of you. Good. So now what happens if, let's say, Don Jazzy, yeah, like actually on Twitter, he is very active, right? So let's say he retweets your startup and it's like, hey, everybody, check this person out, right? And then next thing you have like maybe 50,000 users trying to access your platform or something. How are you going to manage that? I have worked for a company that did everything manually, and To add servers, we'll literally go to the console, click a server and add everything. But then imagine how long that will take me. And then I have, let's say, 50,000 users trying to access my platform. Maybe the first 10,000 would say, this platform is not working. Do you know how annoying that is, right? So manual is fragile, manual is stress. And I call these like vibes and inshallah engineering. That's what I call people that do things like that. Because I mean, yeah, just playing with our lives in summary. I don't know how many people here have tried to access NYSC's website or portal. Like, I think that thing is the worst thing that can happen to you in your life, right? When I wanted to register for NYC, I remember I tried accessing the portal Monday, Tuesday, Wednesday, Thursday. It worked on Thursday. It was going to close on a Friday. So I just imagined, and I was like, what is wrong with your like infra team? Can I meet these people and slap them or something, right? So I just realized that a lot of this is government, private startups, a lot of Nigerian companies kind of just deploy, however, and then they hope for the best. And I also think it's because they normally don't think they're going to have a lot of users. So, for example, all of you that are deploying on Vercel and all this little, I won't call them little, they work on a scale, right? But they don't work on a very, very large scale sometimes. So if you have 10 users visiting your site, why not? But when you're going to have a lot, it's very hard. So manual infrastructure is fragile, it's unreproducible, and it creates something called an environmental drift. I don't know whether you've heard of this word before. So this means that your production server becomes slow, or your production server slowly becomes different from your staging server. That happens. So the environment changes. Because of all the manual changes you've made over the couple of months, it kind of piles up. And then when you enter your staging, it's working in a certain way. When you go to your production, it's working in another way. So I think sometimes you hear somebody say, oh, but this thing works in staging, but then it's not working in prod. So it doesn't scale. That is the problem, right? Period. It does not scale to do things manually. So I don't know if you can see this image on this screen, right? There's this person here, right? Let's say this is somebody that loves to do things manually, and this is somebody that loves to automate their work, right? And let's say there's an incident that happens at 2 a.m. These are different types of people, by the way. This person is like, okay, before this fire blows up, let me quickly fix it. And he fixes it very, very fast. While the person that loves to do things manually kind of just sometimes they sit down and watch that fire expand. Look at it here. This person has put off his fire while this person is still looking at the fire grow bigger. Then, because people that like to do things manually are attention seekers sometimes, what they're going to do is they're going to make sure maybe when there's work the next day, they are going on Slack to send emergency. Prod, let's say prod A is down. We have a big problem, and then everybody rushes, and then there's a call, maybe a war room call. Let's troubleshoot this, blah, 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 blah. And then they fix it. And then everybody's hailing them. So the funny thing about this is these are the kind of people that get the most attention in the office, because I call them attention seekers, like I said, because something they could have easily fixed or done properly in the beginning, they don't do it, and they let it go out of hand, and then everybody's clapping for them for literally doing what they should have done in the first place. So don't be that person, please. We don't like you people. Thank you. So we're going to continue. This is a question to the room, right? So let's say be honest with yourself, but don't be shy, right? So if right now your production database disappears right now, do you think you can rebuild it immediately? Let's say, do you know everything that is installed on your server? No, you know everything that is installed on your server. You know every config change. You know every environment variable, every package version. You're aware of that. Exactly. Except if there's an AI or robot in your head, I don't think you will know everything that is installed on your server, right? So if your answer is no, and for most people it will be no, then your infrastructure knowledge is it lives in your head probably, or maybe you pen it down on some notes. It's all around the place, right? And that is a single point of failure. Let me ask all of you now. In your houses, do you have one door, two doors, or three doors? What do you have? Did we catch my question? So I was asking if in your houses you have one, two. Exactly. Most of our houses will have multiple doors to go in and go out. You can't have one point of failure, because if you do, one day and something should happen to one of that door, you're trapped. You will die, right? So it's literally the same analogy for our real life also. So also, imagine tomorrow you're the only person that knows everything installed on the server, or maybe you wrote it in one book or is in your notes somewhere, and then God decides it's your time to go back to heaven. What are you gonna do? What is your company going to do? You yourself, you're a point of failure. You yourself, like you're a single point of failure. So the goal for us today is to change this, right? We don't want you to be the only person that knows how something works, right? So by the end of this, we want to have like a system where an entire infrastructure can be built from a GitHub repository. So the server can disappear and nobody will wake up in the next morning feeling sick. You just use your code and redeploy everything from scratch. Now, we're going to jump right into the next slide, right? So the goal is for us to build with code, not with your hands, right? So imagine, is everybody here living in Ilorin? Just please don't judge my pronunciation. I think somebody has told me I pronounce it wrongly. Ilorin. No, not everybody's living there. Okay, so imagine wherever you are, you're building a house, right? Please, if you want, you have bought your land, I don't know, maybe whatever dimension is to call those things. I don't remember them, but you have your land. Do you literally just go and start stacking blocks? Like, oh, block, blocks. Do you just go ahead and do that? Right? You don't. You hire an architect. But I'm sorry, this is for Nigerians that like doing things in the good way. Because I know we have those laborers, I mean, those people that used to call themselves engineer that would just wake up and go and start building things for people. And you see structure, the toilet is slanted, the roof is leaking. Not those kind of people. If you want to build something that is really good, you hire an architect first, right? The architect will design your blueprint. Now, infrastructure as code, which is IaC, is that blueprint, right? You have to, you write a file that says, okay, I want 3 servers, then the cloud will obey. If your house burns down, like if you have a fire right now and the house burns down, you can give the architect you can give the blueprint your architect designed for you to your builder again, and it would work, right? So the goal at the end of the day is to define your infrastructure in code files instead of UI clicks. There's something called ClickOps. Who has heard of it? ClickOps engineers or something like that. Okay, perfect. So ClickOps engineers are people that they literally only use the consoles, the UI to do anything. Front-end engineers in the house, you might catch this stray bullet too, but most of the time you guys are addicted to UIs. Like, how many of you ever go to your terminal and say, let me do something via terminal? Well, no, you rather pull up the file explorer and look at things from there. So we call those people ClickOps people. But in general, we have 2 paradigms here, right? And it's imperative, which is the old, which is like what the ClickOps is, right? And you have to, you tell the system what to do step by step, right? So it's like you create a VM, then you say, okay, I want a DIX, then you configure a firewall. It's like you're writing a recipe, right? So step 1, do this, step 2, do that. And then, like I said, you hopefully one day you remember what you do. Personally, whenever I do things like this, I forget it. If I do not document it, I cannot remember what I did. I think there's sometimes if you ask me about some things I did 2 years ago, I have no idea anymore. But that's when the declarative way comes in. When something is declarative, it means you like write it down. You write a specification, right? You describe what you want, the tools, everything. You write it down in a file. So you can be like, oh, I want a Kubernetes cluster with 2 nodes in Johannesburg, right? So you're writing a specification. IaC, infrastructure as code, is declarative. You describe the state you want, and then the tool makes it happen. And because it's a file, you can version control it in Git. We all know what version control is, right? Right? Thank you. Okay. So you can version control it in Git. You can always go back to a previous commit and see what happened and all. You can review changes in your PRs, right? And you can always roll back if something breaks. I personally, I'm very good at rolling back people's changes. I swear to God. If I don't test what you have on PRs, I will roll back your thing. So the infrastructure as code lets you have a history of things you have done, just like your application code. Now imagine somebody you're deploying manually and somebody just wakes up one day and goes to do some nonsense in the server, and you don't even know what they did. You can't, where do you want to start tracing? You will be reading logs, you'll be reading files, like where do you want to start from? So this thing has like a lot of disadvantages, I think is the word I will use. So we're gonna move on to the next slide. Okay, so we have, before we jump in, we have a lot of, what do you call it? Infrastructure as code, what do you call it? Tools. Terraform is one of them. Who can list some for me in the chat? Any infrastructure as code tools that you know, just drop it in the chat. I'm waiting. Okay. Drop it. I think only Noel is on this call or something. I don't know. Okay. So the person that said Pulumi, first time I thought it was Palumi. I swear to God, I was like, am I seeing things correctly? But yes. You guys are all right. Ansible is also a very popular IaC tool. And for Ansible, we normally use it to just write configuration for software, like software configurations. That's what we use it for. So great. I'm happy that you know quite a number of tools. So Terraform is the IaC tool we're going to be using. And I like to tell people, for the beginners in the house, I like to say, think of Terraform like a restaurant, right? You're in a restaurant, you don't go into the kitchen, right? And just start telling the chef, slice onions for me or something. You sit down first and say, I want jollof. Terraform is declarative, like I mentioned. You tell it what you want and it figures out the how. So you're not going into the kitchen and start telling the chef, oh no, that your jollof, please add more pepper and don't put this, or this is how you should cut this for me. No, you just say, okay, I want jollof, and the steps are already available for it to provide that jollof for you. So what does Terraform does, right? Number one, oh, by the way, I didn't mention, let me talk more about Terraform. So Terraform is, like we said, an IaC tool. It was built by HashiCorp. It's also open source. So for those of you that love to contribute to open source, please feel free to go and do that. And it works with literally every major cloud provider, and it is the industry standard. I think mostly you use Terraform. And for those people that are addicted to AWS, like somebody in the house earlier I saw said AWS was stressing you. It's to continue to stress you, my dear. But you can also use AWS Formation. Cloud Formation, what is it called? Yeah, that's what it's called. I have not touched that thing in like 3 years. So, but Terraform is the industry standard. Mostly wherever you go, people will use Terraform, right? So let me just walk you guys through the mental model of how it works. So you write a .tf file. .tf is short for Terraform, from the name. So you write a .tf file like it says here. We have the variables, main.tf and all of that, right? And in this file, let's say the main.tf, you say, I want a Kubernetes cluster with 2 nodes. Please think of nodes as servers in case if we don't understand what that means. So I want the cluster to have like 2 servers and all of that. Then we run a Terraform plan. What Terraform does when you run Terraform plan is it's going to read your file. Then it's going to check what already exists. Then it's going to show you a preview. It will tell you, okay, I will create 3 resources, review it. Does it look right to you? Once you review it and you say, okay, I like what you've shown me, then you can run Terraform apply. So Terraform talks to the Google Cloud API, and then it builds everything for you. The key idea is that Terraform, will handle the steps. All you need to do is declare the result. It will handle all of it. So in this demo, in the demo later on, I will show you how we have like a Terraform file. I think it has about 30 lines of code to provision a Kubernetes cluster, and then you'll see how it works. Okay, so moving on. Now we've spoken about Terraform, right? We're trying to, so here's the thing about tech. You normally don't only get to use one tool. It's not possible, right? You're going to have a collection of tools. It's like when you're cooking, especially, I said Nigerian soups are the most complicated soups in the world. So let's say you're making ogbono or something, you just don't wake up and just put, I don't know, just wet the ogbono in water and boil it and start eating. I don't know, that's just disgusting as I'm even talking about it, right? You will put ogbono, you add ugu leaves, you put meat, you do this to make it right? To make everything flow seamlessly. So that's how it is in tech too. We normally don't use one tool to do things. There are different tools to help you achieve different things. Now, one of the tools we're going to be working with today is also Docker. I don't know, a lot of you would have heard this analogy. I know it's an example they give everywhere. And it's the whole, it works on my machine, but it's not working on this place. We have heard it. I don't want to use it, right? It works on my machine example, but still it's valid, right? So let's say your laptop, you have your laptop, it has what you built uses Python 3.11 version, and then your server is using Python 3.8. Different OS, let's say also maybe your laptop is a Windows, the server is using a Linux OS, and then different packages, different configs. Of course, it's going to give you different behaviors. There's nothing you can do. So the goal is you need to understand containers before you start talking about Kubernetes. If you don't understand Kubernetes containers and you're going to Kubernetes, it's literally like, you waking up one day and just diving into the ocean to swim, instead of you to go to the swimming pool first and test if you drown or not. So you have to start with containers. So, and like I said, the goal is ensuring that we package our containers and it has the same library versions, the same environments and everything. So a container fixes this by packaging your application with everything you need. That's the OS, the runtime, the libraries, the config files, everything. It will package it into one portable unit, and that unit will run identically everywhere. So on my Mac, it's going to work. On your Windows laptop, it's going to work. On a Linux server in Belgium, it's the same. Docker is that tool that builds and runs container. So normally we'll write a Docker file, and a Docker file is just a few lines of instructions. And once we build it, Docker will produce an image. That image is immutable. It does not drift, and it will not change between any environment. And that is the point of writing a Docker file. So I'm hoping that, we're good. We're not confused. Even if we are, I think when we get right into when I show you the code, you'll understand better. Next up is, we spoke about containers, right? We need to package, or let me even say, like, imagine now you work in a warehouse. You need to, of course, you need to put whatever I buy into a box for me, right? Once it's into a box, you have packaged it, you have sold the box. then the box needs to be shipped to me, right? So think of Kubernetes as the whole thing that is doing the shipping and orchestration and all of that. So when you have an application in production, right, you will need more. Docker alone is not sufficient. You will need multiple copies of that application running for availability. You will need traffic distributed across them. You will need automatic recovery or self-healing when one, let's say, copy crashes. And you need to scale up when traffic spikes down and scales down, right? And it scales down when it's quiet. Remember earlier in our example, we spoke about if Danjazi Nashiru, what do you call it? Retreat your startup and then people rush to your application and then you only have one copy provisioned. Of course, it's gonna crash. So this is why we use Kubernetes, right? Kubernetes allows us to have multiple options. So same application, but you can have like 5 to 6. In fact, you can have 100 replicas, whatever money you have, as just ensure that the infra can hold all the 100 replicas, right? And you can also just say, okay, when there's no traffic or when there's traffic, scale up to so amount. When there's no traffic, scale down, right? So that's what Kubernetes does. It is a container orchestrator. Oh, I love that word orchestrator, by the way. I find it dramatic, right? But in summary, you tell it, okay, run 3 copies of my container. If one dies, replace it, distribute traffic around across them, and that's what Kubernetes does. So a few terms you will see in the demo are things like pod, right? A pod is the smallest unit. It runs on your container. I hope some of us are familiar with Kubernetes. Like, I'm just saying, please God, we should be, because yeah, thank God. So a node is a virtual machine, right? Like I said, think of it like a server, and the pod runs on the node. A cluster, as we've been saying, Kubernetes cluster, a cluster is the whole setup, right? The control plane, your nodes, everything, that is the cluster. We have things called deployments. The deployment tells Kubernetes how many pods to run, what image to use, you know, is what is giving it the instruction of what to do. Then we have something called a service. So the service exposes your pod to traffic, whether internally or to the public internet. So we're using GKE. GKE is called Google Kubernetes Engine. It is Kubernetes managed by Google, and you don't have to worry about upgrading the control plane or patching master nodes and all of that. Google does that. All you need to do is focus on your application, right? So if you have ever found Kubernetes confusing, to be honest, just think of it like it's a massive, highly automated restaurant kitchen. Literally, just think of it like that. So, and this diagram shows 2 main parts of the kitchen. This is, let's say the control plane is the management team, right? Of course, you have people that are managing, maybe managers and all of that. The one that is checking who is coming late, the one that is checking who is sick, you know, like HR and all of that, right? Think of the control plane as that, and think of the nodes as cooking stations. We good? I hope so. So we're going to move on to the next slide. And that is the continuous delivery pipeline, right? So we've had CI/CD like a lot of times. In fact, when this event was being announced, they mentioned it, you know. I know we've seen it everywhere, right? And we all know what it means. It just means continuous integration, continuous deployment, but I'm still going to break it down just in case some of us are not sure. So continuous integration means like every time you push a code, right, an automated process kicks in. It builds your app, it runs tests, it checks for errors. If something is broken, you're going to find out in the minute because the test will not pass. But if you don't do this, so you find out in another way. And continuous deployment means that, okay, now if those checks have passed, so let's say our code push pass, build pass, test pass, deploy passes and everything, go ahead to like deploy it. That's what CD means, right? So take it to production. So automatically, So you don't need to go and be SSHing into one server. Let me even ask, for people that use servers directly, how do you get your code to the server? Just a quick question. I want to mock you. Do you use the fast transfer protocol like FTPs? What do you do? How do you get your code to server? Are you using the move command? I don't know. How do y'all do it? So, because if you do, I'll say we should admit you people in a hospital or something. Because you can't be doing that in 2026. Please stop it. Thank you. Anyway, so like I said, there are different types of CI/CD tools. I don't know. I want you to tell me the one, just guess the one we're using for today. Tell me in the chat. Which of the CI/CD tools do we think we're using? Guess, guess, guess. Somebody said they use SCP. Wow, wow. Habib, we need to talk outside this. So, okay, we have Bitbucket. Habib, we really, really need to talk. Nice. You use Bitbucket. Okay, Noel got it right. GitHub, you did not type it completely. So I wanted to give a prize for it, but it's not complete. What is Git Actions? You people also forget that Git and GitHub are two different things. Please be clarifying. GitHub is the platform. So GitHub Actions is what we're going to be using today, right? The reason why also a lot of people like to use GitHub Actions is that it's built into GitHub. As we all know, a lot of people use GitHub for their version control. Some people use GitLab, and some other people use some things that, like the Bitbucket people that they're using. So, and it's free for public repos. That's the actions. And I think it's also free for private, but you have like limit that they give you monthly if it's a private repo or I don't even know. I think so. And it's YAML based. As DevOps or cloud engineers, or in fact, every engineer should learn how to use YAML, because literally everything is written in YAML. Kubernetes is written in YAML. If you want to write your pipelines, they're written in YAML and all, right? So you define your pipeline. And when we say a pipeline is what? Steps. This code pushes a step in a pipeline. The build is a step in a pipeline. Everything is a step in a pipeline. So a pipeline is what? Just a set of instructions is what I'll call it. So you build it and it lives in your repo, right? So to be honest, yeah, I think CI/CD is literally the best thing that has happened in engineering, because you don't need to deploy manually ever again, right? You deploy you don't need to be doing SCPs on your server and whatever, right? So you deploy by pushing code, and the pipeline is the gatekeeper, right? If your code is good, it passes all the steps, then you can ship it, which is fairly easy. So we're going to talk about this now. So let's say it's 1 a.m., right? You've been coding for 6 hours. I know people like 24, they don't sleep because there's no network during the day. So they'll decide to wake up at, let's say, 1 a.m. or 12 and start coding. We know your time. And you now went to go and make change to a login page. You're tired, obviously. You have been coding for 6 hours, all because of Nigeria's MTN and Airtel is messing you up. Then you just say, okay, let me just push this thing so that I have something to see on stand up tomorrow. And then you push it. And let's say this is on prod. You deploy it, you just push it directly. Now, if you were doing this manually, right? And there's a bug on that login page, the page that you have pushed is now live, but users cannot log in. Now, what will people do? Your PM, as for those of you that have managers, is pinging you like, hey, 24, what did you do? You know, it's a crisis, literally. Then if you have, you know how now we're in the era of dragging on Twitter, you breach wrong, somebody's dragging you, right? So your Twitter followers are there, an audience just comes and start tagging your startup, like at this thing, you are very useless. Imagine you have a fintech. I I think there's nobody that takes more insults than fintechs. OPay, I cannot access my OPay. Hey, my 5,000, no, you know, like people are raining courses on you and all of that. But that's what will happen if you're doing it manually. But if you're using like CI/CD, you push the code, right? There's a pipeline that will run the test suits. If your login test fails, the pipeline will say, no, this build is rejected. Then what will happen? The broken code will never reach the CD part. It will never get deployed. Your users will never see it. And in the morning, when you wake up and you see your pipeline has failed, hey, when you have maybe had a cup of coffee, you can fix it and then it works. So pipeline is not even just about, because we talk about CI/CD to improve, what do they call it? Continuous delivery also. Because sometimes they say, okay, to ship faster, we do that. But it's not just about you getting to ship faster, it's also to protect you and your brand. Okay, I think that was a mistake. Great. So we're going to be working with 4 tools. These are 4 tools that I have spoken about, right? Docker packages the app into a portable container. The GitHub action is to automate your build, test, and pipeline. Your Terraform is to provision your cloud infrastructure from code. And your GKE is to run and manage containers in production or dev, whatever you decide. So these are 4 tools. Everyone has his job. Together, they build a beautiful house for you. So this is not like a custom exotic stack, because there are different options. Like the tech world is very vast. There are people that don't want to use Docker now. We have things like Podman and all of that, right? There's so many options, right? But this is the standard toolkit at companies. At least, let me say 6 out of 10 companies will use this stack. I think companies like Spotify, this is also their stack. Things like even Shopify, I think, how do you call it? Yeah. Even tech companies in Africa that I know, this is their stack. So these 4 tools, to be honest, if you learn this, you can walk into like any modern engineering team and contribute from day one. And the thing is also, every one of these tools, they're free to learn and has excellent documentation. So the barrier is not access. So it's up to you. Maybe after today, you just go in. For those of us that are still beginners, deep dive into them and see what you can do with it. So before I switch into code, I just want you to know that how it works, right? So in the middle here, we have the GitHub actions, right? Like I said, it has a pipeline. It builds your Docker image. That's what the GitHub action will do. And then it pushes it to a private registry on Google Cloud. We have different types of registry, right? This was the one on AWS. We have the AWS has its own registry. We have Docker Hub registry, they're all there. And the GitHub actions will deploy to GKE. All this I pipeline. So imagine if there's an error in this, my Docker file has an error. The image will not even build. Talk less of it to push, talk less of it to even deploy. So you're protecting yourself, like I said. And once everything works, and we tell Kubernetes to deploy it, on the right is the GKE cluster, right? It's running like, let's say like 3 copies of the app. That is this image that was deployed. It's there. It's behind the load balancer also. This is it, right? And what do we use a load balancer for? I really like to use the analogy that imagine, for those of you that live in Lagos, sorry, but I think that's one of the worst cities in the world. And I'm not playing, like half of my family is from Lagos, so the hate is real. Anyway, but you probably if you don't have those, what do you call it, those traffic cops and all of that, if you don't have them, I'm pretty sure everything's scattered. This person will not know where to go. One person is fighting there and all, right? So the load balancer is to ensure that your traffic disperses, everything is balanced, right, into your pods. You have 10 pods. Let's say you have 10,000 customers. Every 10 pod will take 1,000. Every pod will take 1,000 customers. So that is the goal of the load balancer. Literally in the name, to balance your load. So the load balancer will kind of give you like a public IP for you to check your app and all of that. And at the bottom, we have Terraform. Terraform is what provisions the cluster. And like one time, I kid you not, all you need to do is run like 3 commands and then it provisions everything you want in your cluster. And every piece of this file is in a GitHub repository. Everything is automated. And that is what we talk about when we talk about like the architecture, right? So enough slides. I promised we're not going to do too much talking, so let me deliver on that. And I'll be switching to my other browsers and all of that. So I'm going to show you everything. It's in a public GitHub repository. I'll share the link at the end so you can fork it and try it yourself. And we're going to walk through every of these files and I'll explain what each one does and why. Then we're going to make a live change and push it, and we're going to watch the pipeline get deployed. Then I'm going to break the system on purpose, like, of course, just to see if it recovers. So let's go do that. We're going to be back later. This is the repository. Right, so I'm just going to reload that. So because I was given 1 hour and the 1 hour is almost off, and I'm panicking right now because I just saw the time. We're gonna like breeze through this, like we're gonna run through it very fast. So just gonna get started. So this is the repo. I did write a README just in case because I know that we're not going to be able to do everything together. So the repo is very explanatory. You can do this yourself at the end of this. Please do it and tag me on social media and all of that. I would love to see what you have, but I'm going to explain things to you and show you that what we had to do. So I had to deploy the cluster before this call because it takes about 10 to 15 minutes to deploy a cluster. And I know that I could not do it with you guys. So I did it, but then like I said, the steps are there, you can always recreate it. So because I'm lazy, I like to work on, Cloud Shell, right? Because Cloud Shell has Docker, it has Terraform, it literally would have me every tool that I will need. I didn't want to work on my local because I don't want to run Docker on my local. That's even it. Let me start from there because Docker kind of slows down your system sometimes. So I have everything here. So I ran it, like I said, and I'm going to go through it with you guys. So in the beginning, I did talk about the architecture. We already went through this. Feel free to go into it, dive into it yourself. And I explained a few things. Blah, 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 we've spoken about this. And then this is the project structure, right? That's what we have here. We have this, just the app, which is our app that has a Docker file and our HTML. Then we have Kubernetes files. Then we have the Terraform here. So what I did first was you need to have your Google account. I know 24 shared with you earlier, and try to, I don't know, they will ask you for your card. I think they will. But try to ensure that, I don't know, if you have a dollar card, probably those gray card, it would work. And if it doesn't, you can reach out to me. I'll try to see if I can get free $5 accounts. I don't even know, can we deploy a cluster on a $5 account? I am not sure. But I will ask if there is, I will try to get you guys access and then share with you. So you need a GitHub account. Like I said, I'm using my Google Cloud Shell. It's recommended because it has all of these things installed. It has Kubernetes, Docker, and all of that. So first thing first, let me go back here. You will need to set your project ID in case if you have multiple projects. I'm already in my project, but I still run it. You know how sometimes you do something just to confirm. I know I was in the project, but I still ran it. So that's what I did here. And then you need to enable the APIs. Sorry, you need to enable the APIs. So by that, what we're doing, we're going to be using artifact registry, right? That's when we push the Docker image. We want to push it to the artifact registry, like we mentioned. And so we're using Google's own, so we need to enable that API. Then we're enabling artifact registry. Container is for the cluster, and then artifact registry is for the image we're going to push. So I did run all of that. And I then proceeded to clone the repo. The repo is public, so you wouldn't have any issues when you clone it. And then I navigated into my path, GDG Lauren. And then I navigated to the Terraform file. I ran my Terraform. I applied it. I'm going to go back and still show you the files and all, but I just wanted to show you what I did before now. Oh, sorry, before I ran my Terraform, I created a secret key, and I'll show you why we needed to do this. So just pause here, but then I decided to provision my Terraform and all of that. So it took, I think, about 10 minutes, and then my cluster got deployed. Like you'd see here. Yeah, I think it took 10 minutes here and all. And then I deployed my application, blah, 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 blah. I'm still going to come back. And yeah, this is the application deployed here. Oh, it's not this one. Sorry, I need to reload. So this is it, right? And this is, if you notice, this is manual, right? Is this manual or automatic, guys? Is this manual or automatic? People should embarrass me. Manual or automatic, please. So everything I did here, right? Like this is it. Everything I did here. Is this manual or auto or manual? Okay. Let's go now. Is it only review guys in this place? You see, this is how I know you are confused. Should I go back? Really? Ismail says automatic. Okay. Oh. No, my most active participant. Please don't have network issues. Is it MTN or Airtel? Who should we curse? Auto. Okay. Sorry. And I'm wearing red though. Don't blame us. So manual or auto? Anyway, I'm okay. Yusuf said automatic. Great, great, great. So in summary, all of you are wrong. And it means that I have to go back and explain it. So only review got it right. Look at it. The only automatic thing that happened was me running Terraform, right? But I needed to manually, after deploying, after creating my cluster, I needed to manually build the image. I needed to manually, I think, where is it here? This is it. I need to manually apply all the files in this directory. Like all those are manual steps, but they are manual because this is the first time we're doing it. Do we get what I'm saying? It's like the first time we're doing it, but after you've done it like this, continuously, it is your pipeline that will continue making the changes. So that's why I had to do this manual step. I could not wait to do it on the call because it would take too long. Because they told me 1 hour and it's already 6. So back here, don't forget, guys, if you're doing this later on, you have to run this test, like I said. I'll come back to this GitHub secret key, and then I provision my infrastructure. So I'm going to just go in and explain the files to you, right? So first of all, the actual code, right? We have different directories here, just 3. App, KHS, which stands for Kubernetes. Then we have Terraform, right? That's how my project is organized. So this app itself is the application itself. It is what do you call it? HTML file and a Docker file. The HTML file is very simple, literally. This is, I think, simplest HTML file. Okay, hello world is there. Well, it's very simple. And then we have our Docker file. So this is what the users will see in their browser, right? In production, this could be your React app, your Django API, your Go microservice, the deployment workflow we're building works the same way regardless. That is what is in this app. Then the Terraform, that's the infrastructure as code. So instead of logging into Google Cloud Console, let's say, for example, here, and then I start saying create, okay, I want a standard cluster configure, like, oh my God, why? So instead of doing all of that, we write a file. We describe everything we want in a file. Okay, let me just take this a bit low. We describe everything we want in a file, right? Terraform will read everything and provision it via the GCP API. Then in this directory, that's the KHS directory, we have the, what do you call it? Yeah. the deployments, the deployment manifest. This is the deployment file that tells our cluster, okay, I want 2 copies of this application, expose it on, where is it? Expose it on so IP, you know, and all of that. Then we have the GitHub workflow. It's normally in a .github/workflows file. And this is the CI/CD pipeline, literally. When we push a code to our main branch on GitHub, this workflow will automatically get triggered because we said what? On push to this branch. So if your branch is not called main, it will not work. You get what I'm saying? And you can also run a pipeline on pull. There are different options for this, but we're running on push and the name of my branch is main. So for some of you that are doing it later, please take note. If your branch is master, write master. So once we do this, it follows all of these steps. Like I said, all of the steps in the pipeline. So like I said, we have 4 directories and everything is version controlled in Git. So I'm going to go in depth into each file. So we have the index.html, like I said, right? And once we make a change here, let me try to explain to you. Okay. So this is just like, it's very simple, like I said, and we can focus on like other things. So if we need to get this from our laptop into a server, and not just once, like every time we make a change, we want it to work, right? So that's the problem the Docker is solving. So Docker now has just 3 instructions, very simple. And I'm going to explain each one and why we choose them. So for this line from Nginx Alpine, we're building on top of a base image that already has Nginx installed. For the developers in the house, I'm showing what Nginx is. And Nginx is what? A production grade web server, right? So I think companies like Netflix and Dropbox, that is what they use to serve static content. So the Alpine is a variant of, it's a stripped down variant of the Linux distribution. I think it's about 5 MB or so. And we're being very intentional at this file. Especially for engineers, please only use what you need. Sometimes somebody can just use from Nginx itself, like the base image, the giant Nginx. And then you wonder why your Docker file is taking 10 years to build, right? So of course not. Like I said, this Alpine is just 5 MB. So imagine how fast it's gonna work, right? So a smaller image means a faster build, faster pull, and a smaller attack surface, because you can get attacked the larger your image is. And then we have this line, and what does it say? Copy index.html, user share, blah, 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 blah. You can read it. So what this is just trying to do is we copy our app into Nginx default document root. Do you get what I'm saying? So when Nginx starts, it's going to look into this directory for the files that it wants to serve. So that's Nginx conversion. There's nothing special. You see it like this most of the times. And then the next thing is the port. That declares that the container is going to listen on port 80. This is how HTTP works, right? We know the HTTP and HTTPS protocols. HTTP works for port 80, that's for regular traffic. And HTTPS works for what? Tell me in the chat, what's the port for HTTPS? Okay. Noel is on fire. It works for 443. Great. And also signals, this also tells the Kubernetics which port is going to route traffic to. So when Docker builds, it's going to create an image. Like I said, the snapshot of the entire environment, the OS, the web server, the code, everything together. And it's going to run the same way everywhere, right? Next up, we're going to dive into the Terraform files. So we have just 2 files, right? But before I show you this main, let's talk about the variables. In the variables.tf, this is where we define the configuration that can change between environments. Project ID, I did not put a default ID because every user has a different GCP project. So I could have hard coded my variables, like things I was going to use in this file. But I was very sure that if some people want to work on this and run this lab, they are going to be running Amina Lawal project when it is not your project. So I ensured that you will pass the project when you're building so that Somebody does not say, oh, this thing did not work, but you're passing my own environment variables. Great. So, like I said, every user has a different project. Then we have the region. So the region, they are all defaults sometimes, but they are configurable, right? Like I said, if somebody now in GDG, like let's say Nairobi wants to fork this repo, they don't need to edit any infrastructure code. All they need to do is just pass the variable when they're running it in the terminal. Everything uses default. Now to the main config. So guys, you can change this if you want, or you can work with it if you want. It's up to you. To the main config, right? We have something we call providers, right? This is a provider block. The provider block, every Terraform starts with this. It says, okay, we're talking to Google. If it's AWS, you're going to write AWS there. So we're talking to Google, var, project ID, and project region. Who can tell me where it's going to fetch this from? Where's it going to fetch this project ID and project region from? Anyone? Okay, thank you, Ismail. It's going to fetch it from this file because we declared it here, right? Because we declared it here. So it's going to fetch it from this file. So var project ID is what's here, and region is what is here, because we've already said this is the region that we want to use, right? So great, we're on the same page. And so first resource is the artifact registry, right? This is where the Docker image lives after the pipeline builds it. So it's a private container registry like Docker Hub, but this is inside the GCP project and it's under your control. Only your pipeline and cluster can access this registry. Second is and this is the name of the registry ID and all of that. Second is the cluster. Now this is the main thing, right? Also, just notice how it's just 3 resources for deploying. And if you want to do this via UI, I'm going to show you how to do it. So this is the cluster. We already said to use the variable we defined here, which is what? Ilorin cluster, city cluster, sorry, right? And the zone, we've defined it also. We're deploying it in US Central 1A, that is the zone. And I choose US Central because it's the cheapest. Sorry, it's the default. But in production, you'd pick where your users are. If your users are in Japan, don't go and pick US Central 1, please. Like, it doesn't make sense because there's going to be latency to think about. So pick where is closest to your users. If you're in Nigeria, the closest is for you to pick a region in Belgium. So that's how it works. So once we have this, we have the, like I said, cluster name zone. Then we have the default node pool. So you will notice this is true. Automatically, GKE auto creates a default node pool when you make a cluster. We remove it because we want full control of our nodes, the machine type, the count, the scaling behavior. That is a standard GKE Terraform practice. So we have the initial node count there, and then we also have deletion, protection, false. So this is a demo. I want to be able to delete this thing at the end of the day. In production, you will leave this as true. Because if you leave it as false, somebody can just wake up. I don't know, maybe MTN and NEPA has vexed them that day and then just go and run Terraform destroy. And the whole infrastructure is going to go. So we leave it as false right now because it's a demo. I will take it down. But in real life, please leave it as true. Some people used to have spiritual problems sometimes, so you need to be careful. Great. So third is the node count here. We have the Google Container node pool. So like I said, the node are virtual machines that are inside the cluster, right? We said, where is it? Okay, so we have the machine type, I think that we defined here, if you look at it, right? And what did we see? We're using an E2 standard. So that's like I think 4 CPUs and 8 GB RAM server. It's affordable, I think. So but please, on production, you have to like look at bigger infra. But since this is just a demo, this is what we're doing. So right now, you will notice that we have only 2 nodes. This is a node count, right? And that's what is defined here. We only have 2 nodes. If tomorrow our app goes viral and we need 20 nodes, what are we going to do? You can tell me. Please, you can unmute and talk. Give me a step by step. Tomorrow, you are viral. People want to access your service and you need to scale your resources. What are you going to do if this is your config?
So you might as well just come into your config file and just change the node counts to the number that you actually do want.
Okay, so like here, I just write it here, or where do I go?
No. It's really, I think it's already specified initial. Okay, yes, you just have to change the variable, that particular variable.
Okay, so I come here. Okay,
yes,
and I just put number I want. Okay.
I think so, yes.
You think so, you're right. Somebody is listening. Yeah. Hey, thank you. So that is it. We're only changing one variable. And then we run Terraform apply, and Terraform will look at what exists. Okay, so before she had 2 nodes. Now she wants 20, which means 20 minus 2 is 18 nodes. I did not need to go into here and start doing, okay, create, okay, like this is the cluster we have right now, right? And so I say, okay, so this is my cluster. You see how it's even loading slow? Edit. Then I'll start looking for what to click. I'll start SSHing and doing stuff. It doesn't make sense, right? So all we need to do is update the value in Terraform file, and that's it. So, like I said, I already ran my Terraform apply in the terminal so that I can get this file configured. So when I ran it, this was the step. So first of all, you have to navigate towards the directory your Terraform file is in. And in our case, it is where we have it, let's say here, right? Terraform. So what did I do first? I seeded into the directory, and then I ran Terraform init. So Terraform init is just to initialize like Terraform in that place, in the folder that we're in. Next up, I ran my Terraform apply. Sorry, I didn't plan. Don't mind it, but you should plan for planning's sake. But I knew it was going to work, so I just ran apply. So like I said initially, plan is to see what's going to happen. If it's going to fail from plan, obviously it will not work in apply. So I just ran apply, and I passed the variable. Remember earlier I told you that I made it like this so that everybody can write their own project ID for this Google Cloud account. But if you also don't pass it dash var, right, and you just write Terraform apply, it's still going to ask you, which I think it's also easier. It's still going to ask you, like, going to say, okay, what project is this? So when I did it, you can see what it told me. It said Terraform will create. This plus means it's going to add. If I remove something now, it's going to go minus. So it says it will perform the following actions, and this is it. This will be created, and it said this is the format, Docker. That's for the artifact registry, project, Amina, Lawal, the ID. All these things will come up after it's created, right? Known after apply. And if you want to, then you can see the cluster also. It created the cluster. This is all the information. You can go through this when you run it later on. And then it also created the container node pool for me. So it will then ask you, do you want to perform these actions? Which you have to write yes. But if you write no to, it's your choice, because I don't know why you write it, no, but you can write yes. So it's going to create it. Like I said, it takes a while, and this took about 10 minutes to provision. And that was it. What did it say? Apply complete, resources 3 added, and I had my cluster created from there. Great. Now we're going to move to the Kubernetes file, because that's what you'll see that I started doing next. So the cluster exists now after Terraform has created it, right? Now we need to tell Kubernetes what to run on it. Because literally you have built your house is fine. I come and decorate the house. What should go into the house? Do you want to have TV? Do you want to put yellow lights or blue lights? Whatever you want to do. So you have to tell Kubernetes what to do on that cluster that you've deployed with Terraform. Now, there's a deployment manifest. You'll see it here, right? Just close up. So we have the deployment manifest. The deployment manifest is one of the most fundamental Kubernetes resource type, and it describes the state of your application. So this is the kind we're telling you. There are different types. You can say deployment, you have the kind pod. There's so many kinds you can use, but this is a deployment file, and deployment file allows us to put whatever resources we want in one file. So we said we want 2 replicas. That means what? Kubernetes is going to run 2 identical copies of our container. Remember the image we're going to build here with Docker. So it's what we're trying to tell you that, okay, we want 2 identical copies of this image, same config, and all of that. So later, you can choose to run more than 2 if your cluster has enough CPU information and whatever to take it, right? Because why? We need to have more than 1 replica because 1, we want availability. 1 container can crash, it can go out of memory. A node can even go down. So if 1 goes down, at least another 1 or 2 more should be serving traffic. Your users will not notice. But if you only use 1 and that 1 crashes, of course, your app is going to go down until someone restarts it, right? But with more than 1, you have like a buffer. Secondly, we also have more than 1 replica because of load distribution. Like I said, when traffic hits your load balancer, Kubernetes is going to spread the requests across all the spots. So not 1 container that will handle everything and then get overwhelmed while the others are just sitting and chilling. It wouldn't work that way, right? So in production, you will not hard code this number. This is a demo. Kubernetes has what is called a horizontal pod autoscaler, and that monitors CPU usage, request rate, and it adjusts the replica count dynamically. So this is manual still, because you don't need to do this in production. So it will scale up using the horizontal pod autoscaler. It will scale up during peak hours and scale back down at night when people are not using it. So keep that in mind. Then we have this step, right? So we said containers. This is the name of the container. And then the container has a what? Image. The image field that we have is the address of the Docker image that we're going to build, right? And that Docker image is stored where? Where's the Docker image stored, guys? Where's our Docker image stored? Okay, thank you very much. In the registry. Great. So once we have it there, right, then you will notice that this uses latest. I want you to notice this tag. This is a tag called latest. In a few minutes, I'm going to show you how the pipeline will replace this tag latest with a unique commit hash before deploying. I'll explain this when we go back to the pipeline. But for the last thing here, we have the limits. So we are capping each one at 128 megabytes memory and 250 millicores of CPU. A millicore is 1,000 of a CPU core. I don't know if you understand this, but I hope you do. So why are we setting limits? You might ask yourself, right? Because without them, 1 container can consume all the memory on a node, I swear, and crash everything running there. So resource limits are like guardrails, right? In production, though, you set this based on actual profiling. So you run your app under some load and observe what it usually uses, and then you set the limits. But this is just a little demo, so I just use this amount. Then we have the service.yaml. So the service.yaml is easy to understand. We need to expose the application to the world. The deployment will create the pods, but then the pods have a problem. Their IP addresses are ephemeral. And when we say something is ephemeral, it means it's not permanent. So every time a pod restarts, or whether it crashes or it gets updated or something, it's going to give you a brand new IP. So you obviously can't use that, right? The old one is gone. So imagine you give your customers a phone number that changes every time you restart your phone. The customer will never reach you now, right? So that is the pod IP problem. The service solves this problem. So it will provide you like a stable endpoint, and that endpoint will not change regardless of what is happening to the pods, like pods behind it. So Kubernetes has 3 types of services. We can list them for us in the chat. 3 types of services for those that know. 3 types. There are 3 types of ways to expose your applications on Kubernetes. Anybody? I might have a prize for this person. Hey, sorry, no. If only you remember the last one. Okay, so you have helped each other. Review and Noel, we have all 3 right now. Great. So we have the cluster IP. The cluster IP is what only accessible inside the cluster, right? Other services can talk to it, but the outside world cannot. You use this for your internal microservices like a backend API that only your front end talk to. Nobody outside needs to access it. The node port is just like it's going to open a specific port on your cluster. You can reach any app at that node's IP plus that port. And it's not really an ideal part, but we're going to be using the load balancer. So the load balancer asks Google for a public IP. So the load balancer, like I said, will distribute your traffic across ports, and it does not change when the pod restarts. And you will notice that we said type load balancer. The port is 80, that is the external port, what users will type in their browser. The target port is the port on the container. And why is that? Because Nginx listens on port 80. And the selector app is what? Ilorin Watch. Now, this is how the services will find the right ports. You notice Ilorin Watch is here, right? So now go back to deployment. You will see it here. We have what? Metadata labels, Ilorin Watch. If we don't have this metadata labels, Ilorin Watch, defined here, the deployment will never know what service to use. It doesn't know what you're saying. So you have to match it like, okay, I want you to look at this app with so-so label. And that's how that works. Now, the last part of our explanation is the CI/CD pipeline that you have seen here, right? So, like I said, on push is where where you push, right? You don't need to do SSH, no file transfer protocols, blah, blah, blah. You just push your code and it does the rest. Now, there's this env step, right? It has the project ID, registry name, and all of that. You can create this in your GitHub secrets. I think it's you come here. You come to GitHub secrets. You come here. You go to actions. You go to general. What am I doing? Okay, it's here, sorry. Wrong place. Okay, so this is your GitHub secret. You can define all of this here. So you can just say project ID, pick it up here, new repository secret, add it. But I was just a bit lazy, so I decided not to, because these are not variables that will harm me. So I just did it here. So you can either do it there and reference it here, or you can do it like this. But this is demo. In production, you don't do it like this, please, because I'll show you how is the normal way to do it. Now, the step 1 is we are saying what? Check out. Check out means pull the latest code into the runner. What is a runner? The runner is like a fresh Ubuntu VM that GitHub will spin for every workflow it can run. It's a clean state every time, so there's no leftover or cache builds from like previous builds. Next up, we told it to authenticate. It has to log into my Google Cloud account using my service account key. Now, the service account key, let me explain this because you will need it. So if I come here, there's a step I skipped earlier, right? Here, when I spoke about, I think step 2, how to create a service account key. This is how you can create one. So in Google Cloud, a service account is like a non-human identity. It is not tied to any person's Gmail account. It is specifically for automation. You create it, you grant it the permissions it needs. And in our case, the only thing we needed to do is pushing and deploying to GKE, nothing more. So there's something called principle of less privilege, right? You only give what is needed. If somebody needs to push and create an image, don't go and give them as admin role. It doesn't make sense. So now this service account key or the pipeline that is using my service account key, in case one day if I'm hacked, imagine the service account can access my billing or delete my account and read my emails. Like I'm in harm's way, right? But the key doesn't have those permissions, so we're safe. Now, the key for this account is like a JSON file, right? And it's stored in GitHub secrets, like I showed you over here. This is it here. I created this myself earlier, and it's encrypted at rest, and it's only injected into the pipeline at runtime. It will never appear in the logs. Even today, if you fork my repo, you will never see this secret. It's not on your own. You can't see it. So you will create this on your Google Cloud Shell, the same way I did. So this is it. This is the name of the service account. This is display name. This is the permission. I wanted to push to Docker. I wanted to push Docker images, and I wanted to deploy to GKE. If I didn't have this, I would never have been able to. Okay, no, not now. When I run the pipeline, it would not work. Next up is you create the key here, and then you try to display the key, then go to GitHub, secret variables, add the key, and then don't forget to delete it from your local. So that's what I did here. And when I come to my IAM, I can see it here. You see, this is it, GitHub deployer at Amina, Lawal, blah, blah, blah. And these are the only roles it has. So you have to do that, or else your pipeline, it will not work because it cannot authenticate to Google Cloud. Next up, it set up the Cloud SDK, and it configures Docker. Simple thing. The Cloud SDK means it's going to install Google Cloud, that's G Cloud, and it's going to tell Docker how to authenticate with the artifact registry so it can push images. Next up, we're going to build the image, like we said. And the image, we used GitHub SHA. This is the commit hash. Each commit has a hash, you know that. So we want to reference using the commit hash, and then this is how we push the image to the artifact registry. Then step 8 is we connect to the cluster, right? env cluster name, env cluster zone. This is what we defined here. Look at them here. Then we deploy to GKE. Now, there's something I need to explain here. If you look at the first line, this command, set-i latest k8s deployment, blah, 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 blah. So the problem is our deployment manifest says the image tag is latest. If you look at it here, what does it say? Latest. If we build an image and we tag it latest, and then we push it and run kubectl apply, Kubernetes is going to compare the image tag in the running environment already with the tag in the new manifest. Both of them will say latest, right? Kubernetes will say nothing has changed, and it does nothing. It will never push, no code will be updated. It's going to remain in the old version because it is looking at the same tag, latest. This is not a bug. It's how Kubernetes works. It compares the specs of the previous and current one. If it's the same thing, it's going to say nothing needs to change. So the fix is every time we want the build to have a unique tag. That is why we use GitHub SHA to get a commit hash. Like, I think the commit hash are like 6 alphanumeric digits, right? 6 or 7, I can't remember. But it's going to be different every single time. So can we solve this differently? Of course. I know somebody will tell me, oh, can't you use kubectl set image and just update the image directly, right? Without touching the manifest and all of that. But sometimes that creates drift. Your GitHub repo will say another thing. Your cluster is running with another one. But with this approach, which is what most people use, the manifest is always the source of truth. And that is the foundation of what we call GitOps. Git is the single source, source of truth and all. So after you're done with this, you're going to do your kubectl apply, and then it's going to send the update to the manifest and all. So now, enough, we're going to just go in and just test something out. So like I said, my cluster has been deployed. My service account key has been created. When you want to run this yourself later, I've done step 1 to 5. It's already done. So I just want to show you how it's going to be in action. Now let's go back to my Cloud Shell. I'm going to go to my index.html file. And I think let's make some changes here, right? So when we deployed it, sorry, let me just go to my Cloud Shell. When I deployed it and I say, kubectl get all, it shows me, oh God, it has logged me out. So Let me relog in. But if I run this, let me just show you guys. I think I did it here. Okay. So QCT, I get all. This is it. I have 2 pods running. I remember the 2 pods are the 2 replicas we defined here. And then this is my service. The service, what did we say here? It's a load balancer. It tells you the type. It tells you this is the IP. Earlier, the IP was not provisioned. But then this service, Kubernetes automatically creates when it's creating the cluster. This is the deployment file. So this file is what provisioned these 2 pods. And yeah, it will create a replica set also. So we have, when I tried to get the service IP, this is what it gave me, external IP. And this is what I put in here. And this is what I was seeing. This is the IP. So if I give you this IP now, it probably would work, right? But, so it's running on GKE. It's served from the data center. It's accessible anywhere in the world, literally. So what I want to do now is I'm going to change this index.html. I'll just show you guys something. From, let's say we have blue here. Maybe let me make it green. Oh, I like that green yellow. Oh, no, let me make it red. Yes. And then let me say hello, Noel, with our, and Adi. I don't know. Are you good today? And then let's say this is version 2.0. I'm going to remove this because we deployed this earlier manually, but this is going to be automatic now. All right. And yeah, what did I change? Just 3 lines, right? If I was doing this manually, I have to go to the console. I don't even want to start, man. I have to SSH and do some stuff. So I'm just going to push this file. I'm going to push this file and I'm going to be like, sure. So while I push this, I'm going to push. You can do your git commit and git add, though, please. I know I'm just lazy right now. So I just use the terminal. So once I come to my actions, so once you're in your repo, you go to your actions here. You see, this is the commit we made and I can see it here. So what? I go in and what is running the pipe, the steps we had here. Where is it here? The steps we saw here, right? Step 1, step 2, step 3. That is what is happening here. So what does it do first? It authenticates. Take me out. What does it do? It checks out the code, like we mentioned. I set up Google Authenticate to Google Cloud. If I don't have my service account key, it's going to fill here. And then we install Google Cloud SDK, we configure this, we do the Docker build, we push the Docker image, we deploy to GKE. So you remember earlier what I told you, how we use sed and all of that. So let me show you guys something. So this is the credentials it uses. Okay, so we're live. Once we push this and we come back here, what do we see? Oh my God, this hurt my eye. Well, when you get the gist, right? So that was in how many? Was that up to a minute? It was very, very fast, right? So imagine that every time you change your code, it automatically just gets deployed, and that was fast, all right? So we can quickly test something, but I think we're out of time and I need you guys to do the quiz before I go. So initially I wanted to like delete a pod so that you can see what will happen. But if I should delete this pod now, it's automatically going to reprovision another because the deployment manifest says 2 pods, 2 replicas. The control plane is going to be like, oopsie, one is missing, provision another one. So that is how it also does self-healing and all of that. So remember, for the secrets, please feel free to add the secrets from the settings, please. Actions. I just did this because it was a test. Like I said, I was a bit lazy. because Noel is shouting in the comments that she never had code secrets. Thank you, sir. Anyway, and yes, Ahmed, you're right. We can do like semantic release tags and all of that. You're right. That's also another option. And Joba says, what happens if the 2 pods are gone? Yes, automatically, as long as your deployment file is not gone, it's always going to reprovision those pods. There's nothing that concerns it. And if you want more replicas too, you can go and increase it from the deployment file. It works, is that easy and all of that. So like I said, later on, you can kill the pods. It will always come back. So now, in summary, we use Terraform to provision our infrastructure. Let's remember that. Terraform to provision the infrastructure. If tomorrow you want to update your, what do you call it? Version, you want more nodes, it's very easy to just change it from there and run your Terraform apply again. We use Docker to package the app, and that is what build the image. This is an image that we're seeing here right now, right? Good. Then we use GitHub Actions to automate deployment. So in future, whenever I need to do something, all I need to do is push to main, it's going to rebuild the pipeline, and that's it. Then we use Kubernetes to run and manage the app. So it has things like self-healing, load balance, and it has 0 times updates. So 4 tools, right? Everything is integrated. Like I said, this is if you're a student or you're in your early career, even if you're a front-end engineer, this is like such an important skill to have. And every tool I use today is free. Terraform documentation is excellent. Everything is interactive. And please feel free to build something, fix to ship, and whatever you want. So now we're going to find out who was paying attention, right, in this. Also, before we move to the quiz, let me just answer a few questions from you guys. Okay, so I have, sorry, just give me a minute. Okay, so let's get right into your questions. Somebody said, what? Okay, you said, does it not affect CPU and run up costs? So here's the thing. Kubernetes itself is a bit, I won't call it expensive, except, so the problem is we tend to over provision things, right? If you are a startup right now and you have just like maybe 2 microservices, 100 users, I will not tell you to go and use Kubernetes because I don't know what you're going to do with it, right? But if you are, let's say you have a lot of microservices to manage, you have a lot of users, there's traffic and all, Kubernetes is the best option right now for you. But if not, you can look at things like container solutions, like things like Fargate, Cloud Run, and all of that. There are other options, right? And for it affecting CPU and run up cost, so if as long as, that's why we set resource limits, if you remember, each pod has its resource limit, so it doesn't really go out of what you have defined. But if you don't define it, of course it's going to affect CPU, and it will not provision what you didn't, the specs the cluster does not have. If your cluster does not have enough memory, everything is just going to tell you, maybe you're going to see your pod crashing, it's going to tell you image pullback error, pending, you're just going to be seeing errors. So that's why you ensure that you have enough resources on your cluster. Like, it's something that is very important. And then the next question says, how will I advise migration from a PHP project that is being run with Laravel boards? God, we discriminate against Laravel people, so I'm going to try to be objective, but what, honestly, like, why I don't like Laravel Forge is because it treats it like your servers like pets, you know. You name them, you care for them and everything, but the day you want to migrate, start acting mad and all of that. So if I were you, to be honest, I think the hardest part is to decouple like the state, right? So before touching the code itself, right, I would move from, let's say, I'll move the, what do you call it, database. I don't know whether you're using Postgres, SQL, and whatever. I'll move it to a managed database like Google Cloud SQL or RDS. That's one. Then 2, I think maybe your uploads, whether you have images, docs, and all of that, I'll move all of them to an S3 bucket or Google Cloud storage. I know normally on Large Forge, you have it in your storage folder, right? I think that's how it works. I can't remember, but I think so. So if the server dies, your data is safe. That is the first one. So that means your app is stateless right now. Before you start anything, just remove all the data. Next up, I think you can stop Forge uses scripts also, if I'm correct. So you can just stop, please, using it to configure your server, write a Docker file, right? You can create a Docker image that has PHP, Nginx, and all the extension your app need. Test it locally if you can, and if you do it, you can also deploy it on Cloud Run, Kubernetes or even a VM, whatever you decide. And then I think the last thing probably is where you want to deploy it. So you decide if you want to go on Google Cloud Run, or I think there's the AWS App Runner too. It will handle the scaling for you. And it's ideal if you don't have a DevOps person on the team. But if you have a lot of users and you have traffic and all, go to Kubernetes. Honestly, it gives you full control, but it's a bit complex. So you can also, I think, Shadi, let me just stay here. So couple your data, that's the first step. Containerize the app, and then you ship the traffic. I think that's the easiest way to do that. So if I've answered your question, we're going to move on to the quiz. So we have our quiz, and it's 2005 question. It's on Slido. I will kickstart it. Ooh, I don't want you guys to see my screen. Give me a minute. Let me stop sharing. I hope you can see my screen. Okay. Okay. Ladies and gentlemen, shall we? Let me share. I mean, I literally displayed that QR code for like 1 second, and these 2 people have joined. So I think it's 10 questions. Each question, I'm going to pick the person at the leaderboard. So it's how fast you click your answers is going to be what's going to get you high on the leaderboard. And for each question you click that is correct, it's like 2K prize. So everybody feel free to join. I'm going to give I think 2 minutes. It's already 2:45. I'm sorry, 6:45. I'm going to give to 6:47 for others to join. Okay, let me share the link. No problem. Let me see. Oh, I think my internet is starting to lag. The link is in the chat. Feel free to join. So we have 1 more minute before we start. Why am I seeing 224s? 24, this life here I want to play. It's not good. Ready?
Oh, okay. Maybe when you're done.
Okay. Okay. So is anybody else joining before we get in? Okay, I'm reading the chat and we have areas. Okay, so ooh, I like it. I like it. So wait, are you saying 10K per correct question?
No, I think now his thoughts were if 2K is the prize like for the winner at the end, if that's your
Okay.
prize. So we're adding 8K to you to make it a whole 10K one. Do you understand? For the top winner.
Oh, okay, that's no problem. More money for the winner. Oh no, it was like per question that you get correctly, you have
Yeah.
like 2,000. So if one person gets all 10 questions correctly, it's like 20,000. So that was the plan.
Oh, okay. If that was the plan there, and you were trying to pick how many persons?
Okay, so we're doing 30.
How many are you picking one person?
Yeah, one. I'm
All
not.
right, cool.
Wait, so I think I can speak, right? I mean, this is incredible. I've never really paid attention to anything like this. I was probably like I was
Mhm.
texting Imam to kind of say, "Yo, what's your LinkedIn?" Things like that. Anyways, my sort of reserve is that okay, since it's 20K at the end, I'm
Mhm.
gonna make 30 so that it's 50, and I think we should be that should be like a lot more better for the winner.
I think then we can split it to first, second, and third.
Okay, even better, even
That's
Yeah,
better.
fair.
that works
That's
better.
fair. That's fair.
Please, can we clap for him? Like energy. This is fun. Oh, look at this person. So before our 20K was too small for you, right, OS? So are we waiting for anybody else? Ready? So are we waiting for you, OS, or not?
Somto is a big man. He doesn't need to join.
Should we wait for him,
Somto is a
guys?
big man, honestly. We don't need to wait for him.
Really? It's not good to be evil. So please, some questions. Just to be, let me just walk you through it. They're like 20 seconds, some are 30 seconds. So please, there's even a question that is like 1 minute. So feel free to scheme and answer fast. The fastest finger is who is going to end up in the leaderboard at the end of the day. So we're ready. Yes, Habib, you can still register. Is OS here? Ah, OS, bye-bye. Because what do you mean? What do you mean network?
Let's go ahead. There's no time, honestly. He'll meet us on the way.
Right. Okay. Well, it's had whatever Habib. Is he still joining? Okay. So we already have 30 people. Let's go. Mhm. Hey, question one. Dan, shall I reveal the answer? Leaderboard. Okay. Let's go. No. No. That was bad. Hmm. Hmm.
I don't think Somto is participating for him to be saying that play get with ginger was. I don't know how Blessing came about to
Who's
come and overtake
who?
everybody.
Like, I
Uh,
don't know. Blessing is on fire.
she's getting everything correctly. I think Noel missed 2 questions now, which is why he's
This
going down.
is really the case of nobody who called police, they win case or something.
Exactly. And look at Somto too, number 2.
Hmm.
OS.
Anyway, next question. So I didn't delete the pod, but I explained it.
This is crazy. I want to know who Blessing Oscar is. Let me go and Google her.
Okay. At least I know like 70% of people were listening to me.
Are you serious?
So this is the last question. We're ready. This is what determines your winning. So let's go. No, I didn't remove this.
Then it's the initiative, man. This is what I mean. The price is.
Wait, it's fastest finger. Fastest finger. Fastest.
Everybody picked it.
What the-
How?
No, this is not fair to Blessing. No.
How?
Blessing, what happened?
Ariel, are you Blessing? I don't understand what.
Of course not. I'm just joking.
Where is
Oh,
Noel?
Arius is Blessing.
Oh, okay. Just joking.
Oh. Anyway, so we have OS as the first winner with 8 questions. That is how much? $16. So congratulations, OS. At least you have one data software month. Then we have Noel. Why does everybody has 8 questions? Wow. So here's what we're gonna do.
1, 2, 3.
No, we hook up police, I think. So now I'm thinking, should we still do our 2K per question? Because I don't think it's fair.
No. What do you think we should do? Let's tell us what we should do.
I don't know. Arius, what do you think also?
I think
we
let's
should go
just
with the fastest finger that you said.
Oh, as usual, you can talk.
Sorry, I think you said fastest finger, right?
Yeah, fastest.
So Elias, you can still talk. Sorry.
You know what I was thinking we should do is just put it in Gemini and tell it to divide it by first, second, third, but making first the largest number so that it averages out towards the end.
Mhm. So I think if that's the case, even from my head, the first can take 25, the second can take 15, and the third 10.
What will call
Sorry? Who wants to fight? This is a fair game.
Go to court.
is there any price for the Olodos?
Let me
encourage
push
us.
this. Let me
At
push
least
this to your organizer.
At least encourage us to do better.
I'll push it to your organizer.
So I mean, so let's just do it this way. Okay, just the way you mentioned. I think that it's still the same 50, right? So they would have to like send me or send should they send it to so now what you do is send a message to this number. I'm gonna type my number here. That's my WhatsApp number. And I think I know all of you. I know Noel, I know Sonto, and Joba is JB, right? Right? So, and okay. So that means algebra. I think I know everybody. That's crazy. So OS, Noel, Jobber, and Algebra. Please send me a message on WhatsApp, and I would distribute all of this to you guys. And yeah, so back to you, Amina. You're muted.
Sorry about that. So yeah, I think that's all for my end. Like I said, fourth and fifth, we'll also try to get something to reach you all. And for those bottom feeders, I'm just gonna accept that you were not listening, or maybe I was not a good presenter enough for you. And if that's the case, I'm sorry. But for those that were okay with the session, please feel free to run the labs. Like I said, you can connect with me on LinkedIn. Let me quickly get my account URL, and you can send me a message or whatever. And then we can see if you have any issues running the stuff, right? I can always help out. And 24, please just send me an email so that I can send the cash gift to you also. And is there any questions from anybody? If there's ever any future, maybe you want another session or anything, you can reach out to 24. I'll be happy, always happy to contribute my knowledge to everybody. So thank you, DDG Lauren, for organizing this. And thank you so much, Arias, for contributing and making this more entertaining. This was a nice session. I think this is the first technical talk I've had this year, and I think it's going to be hard for anyone to beat it. So thank you, guys. And OS, thank you. Thank you very much. So I'll let you, I'll pass the mic back to you. Oh, let me also send okay, for the resources, link to repo and all of that. 24, should I send it to you and then you share with the community? Okay, perfect.
Yeah. I think what I would do is, everybody registered, so I can send email to everybody and they will get it. And I will also send it to you. So we have a community on WhatsApp. So I'll also send it there so that others too can get their hands on it.
That works then. So thank you all and have a nice day.
You guys should. I think at this point, I need like a lot of flowers, buzzes. I want to see more clappings. And this is our first event for the year. And I mean, for a very long time, we've not done a virtual event. It's always been physical, right? And I'm happy this was very, 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 very engaging. Thank you very much, Amina. All thanks to you. Very, very solid. I've been seeing some feedbacks from WhatsApp, right? And this was very, very interesting. Thank you very much for sharing your knowledge with us, the community. And I believe that so now to even make it better, right? We made it, we're recording this session just so we could upload on our YouTube. We have a YouTube channel, that's for the community. And this is now a call for everyone to please search for DDG Lauren and give us a follow there. The reason is because most of the technical sessions that we have, we try to record them and we upload it there for references, and people can always go back there to watch it again. And because this is a technical session, you may want to come back to it to kind of like see, okay, yeah, I missed this particular part. What does it say? So it just makes a lot of sense. And you would see that we have some videos there. These are from our past events, which is their first last year. And those events are pretty much about what's it called? All the workshops that we had last year are on there too as well. So I also share with you guys the link to Amina's profile. Well, before we do that, I want to let you know that we'll do this more, and we're trying to like focusing on Google technologies. We'll touch other technologies as well, but first we are touching more of Google technologies because it is our responsibility to make sure that people that are from our community are educated about Google Tech, because that is the community that we are all about first before any other thing. So yeah, we'll do more of this. And Build AI learning is coming by March. And this is just to let you know ahead. And attendance is strictly by approval. So because we have a strict number of persons that we want, so obviously you would have to apply to join, and then based on your application, the page will be up publicly on our Luma page, just how you registered for this particular event, and then behind the scene we will now approve based on your reasons. And the next community series will probably be one at the end of this year, at the end of this month. And then we would have another one in March, April, June, continuously like that. And obviously the big guy, Defense Lauren, we did it last year, November. So yeah, this year again should come around that period. You didn't hear it from me. So yeah, there'll be other things that will still be coming up, but that's first what I want to share with everybody here. Then at the same time, if you're not a part of the community, the DDG events platform, where you can always get updated messages, emails fast before any other person. Sometimes we even send some memos to the community without even publicizing it on our social media. So it's very, very nice for you to join the DDG platform using this particular link here. Sorry. No. I have to go back. back. Previous. Yeah, okay. So now, this is Amina's X platform, or X handle rather. It's Amina, AMIYNARH. So if you have some feedbacks, you made screenshots, you enjoyed the session, and you want to tag her, you want to connect with her, she's a very, very solid cloud engineer, so cloud specialist, to be very, very specific, because this is not just your roadside professional, right? So she knows her onion. So it makes a lot of sense for you to give her a follow. If you have anything that you want to do, or you actually did this project on your own, you can tag her just to get her maybe her comments and any other thing from that as well too. And this is our LinkedIn. We have a community platform on WhatsApp. If you want to join, just send a mail to us, ddglawrencmty@gmail.com. And on these notes, I wanted to, Arios is our DDG lead organizer. I'm just an errand boy. So Arios has been the lead for very, for a while, and he has been the backbone of why our community is flourishing. So I would, on these notes, give the mic to Arios to give us the closing notes. Or before he comes up, if anybody has any question, feedback, before we close out for the day, if you have any question, this is the time for you to ask. Questions, feedbacks, anything. How was the session for you? I don't know. I feel like you guys can do more of. I want to get like more response as regards to feedbacks. How was the event for you? How was it? I mean, we initially planned for 1 hour, but this is an hour 11 minutes, and every minute is should I show it here? Every minute is very, 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 very worthwhile, right? So, okay, I'll just share the link to the community in the chats. But while I'm waiting to do that, please, I want to get more feedbacks. How was the event for? How was the session for you? This was very, very, very well thought of. We didn't just do. We didn't just say, I just have this particular session. We looked at what the community needed, and then that's how we decided. So the next one will also be probably about AI, Anthropic. I'm sorry, it will be something around anti-gravity, right? Or Flutter. So one of these two. I'm just giving you guys a hint right now. So when it's up, you probably see the email, or you get the notification through our social media handles. So invite members, send link to via WhatsApp. I'm trying to copy the community. What's it called? So in the community, we have a Defers Learning pop-up group, which is just like a chat, right? And then we also have the main group, and then we have a GDE pipeline. That should be private. You really don't have any business with that one for now. So it's a community, so you can just request to join the GDG Learning community. So here is the link. So for those that are asking about the slide materials, the GitHub, everything, you would get them. I'll compile everything and send it via email. As far as you registered for the event and you're here, you get it in your email, in your inbox. I'll also send it to the community group. So yeah, that's how you would get it. And for those that won their prizes, so send a message to my WhatsApp. I'm expecting 5 persons. I listed them out here. So OS, which is Somto, Noel second, Joba third, and so Amina said we should add fourth and fifth, which is Blessing and Algebra. So so just send me a message on WhatsApp. My number is up here. I'll just pin it now, so you should be able to get my number on WhatsApp. Text me, and I will distribute that to you as soon as it's available. So, any other thing, any question? All right, Arius, can you please give us a closing remark and we can close it up today?
I'd like to say thank you very much, Amina, for showing up and sort of doing this. I felt like a lot of people don't really understand how difficult this could be, even though some might say, hey, it's a virtual session, so it shouldn't be difficult. It is, guys. The ability to be able to coordinate, in my own perspective, I even think it's a lot more demanding than in physical, because in physical you could just say whatever you want and move on, but in virtual you need to also go back, and then there are some people who are struggling with network, and you need to summarize as much as you can, which is all she has been doing, and saying that she'll go back even if people don't understand. And I think that's very underrated. Not many people do that, and we really appreciate you. And then to 24, thank you so much for putting the show on. It's really, really amazing. At first I was even saying, why are we doing this? Because we all know the drill around the virtual events. There's always people not having networks. There's always the host cutting off in and out, but this was refreshing. In fact, I've texted you about how we could do more of this, because we've been sleeping on this, because we've had terrible experience on virtual events. Also looking forward to posting the recording on YouTube as soon as possible. Thank you so much for taking your time out if you attended. And the rest of the team, it really means a lot, your little contributions here and there. Thank you very much, everyone.
Thank you very much, everyone. And I'm sure Amina is very happy, and she's seen all the feedbacks that are here too as well. Thank you, everybody, for sharing. And on that note, we say thank you, and we'll see you again on the next time. Bye.